Take this question from velocity time graph, and you are given this graph of velocity against time. The question says, over what time is the vehicle accelerating? Over what time is the vehicle traveling at a constant speed? And over what time is the vehicle decelerating? That's a part of the question. Now we need to understand this velocity time graph very well. That starting from point O, meaning that the body starts from rest. From point O to point A, you can see here that the vehicle accelerates uniformly because a straight line velocity time graph represents acceleration. Thus, if the graph has a positive slope, positive inclination, angle theta is the angle of inclination. So, which means the body starts from rest and then accelerates uniformly, reaching a top speed of 10 meters per second after a time of 20 seconds. Then from point A to B, you can see that the speed neither increase nor decrease. It moves with a constant speed from A to B. This is a graph of constant speed. So which means between this time and this time, the difference between 70 and 20 is 50, which means for 50 seconds, the body has been moving with a constant speed of 10 meters per second. Then from B to C, this is a case where the speed of the body reduces steadily, slowly. You can see the downward slope until after 100 seconds here, the body is at rest. That is because the speed here is 0. It's now at rest at point C. So from B to C, the speed of the body reduces gradually, steadily, slowly until the body comes to rest at point C. So we can come back and look at this graph that it has about three stages. The first stage is when the body is accelerating, because from O to A, the body has acceleration and the acceleration is constant. Okay? Between A and B, the body's acceleration is 0. It means the body is moving with a constant velocity. And between B and C, the acceleration of the body is negative. I'm going to show you that in the course of solving this problem. Negative acceleration, recall I told you earlier, indicates or represents deceleration or retardation. So we have the region of uniform acceleration, zero acceleration, which is constant velocity, and the negative acceleration, which means decreasing velocity. So the velocity decreases at a constant rate. So the question, let's come back to it again. Over what time is the vehicle accelerating? Between 0 and 20 seconds. So for 20 seconds, the vehicle is accelerating because that happens from 0 to point A. That corresponds to time 20. Then constant speed is the difference between this time, because between A and B, the body is moving at a constant speed, which is the difference between 70 and 20. That gives you 50 seconds. And then that's for constant speed, 50 seconds. Then for deceleration is it starts decelerating here. The brakes are applied at this point B. Okay, because before a moving vehicle comes to rest, of course, the driver must engage the brakes. Of course, he must apply the brakes to the vehicle so that the speed of the vehicle can gradually reduce, or the vehicle can be brought to rest gradually or with a constant deceleration. So this time, which is 100 minus 70, 30 seconds is the time for deceleration. Okay, now we have to calculate the distance, the acceleration. The B part says find the acceleration of this body. And the acceleration is calculated in the part OA of the graph. And that's going to be how to find out by the slope of the graph, which gives us the slope of the graph is change in velocity, which is 10 minus 0 over 20 minus 0. That is, this is like my V2, my point 2, V2 10 minus V1, which is 0, over 20 minus 10. That gives me 10 over 20, which is 0.5. So my slope is acceleration. My acceleration is 0.5 meter per second squared. Okay, so we're looking for the deceleration now. Deceleration will come to this part of the graph. Line BC can be used to find our deceleration because the body decelerates over this time 30 seconds, that is from B to C. So I can decide to take point C as my point 2 and the point B as my point 1, so that my slope of that line BC is 0 minus, because this is my V2 at point 2. That's my final velocity, which is 0. The initial velocity V1 will be 10 over where I took my V2, exactly the same point. I'm going to take my T2, which is 100, minus T1. This is my point 1. Take it out the time as is. That gives me 70. So that gives me minus 10 over 30, which is minus 1 over 3 meters per second squared. Now, since this answer is negative, I'll finally write my deceleration as 1 over 3 meters per second squared. That is my retardation or deceleration. Okay. Now, the total distance covered. The total distance covered is given by the area under the graph. Area under the graph represents the total distance covered. And the shape of this graph is that of a trapezium. And the formula for calculating the area of a trapezium is half the sum of the two sides that are parallel, sum of the parallel sides times the height of the shape. I will identify the two sides that are both parallel. I can see side AB parallel to side OC. This line and this line OC are both parallel. So that my A is this AB, my side B is this OC. So the length of A is point B is at 70, point A is at 20. So 70 minus 20, that gives me 50. My B is all the way, the distance from point O to point C, that gives me 100, times the height is along the vertical axis, which is 10. So that if I evaluate this, I have half times, I'm going to have that into 150 times 10. That gives me 2 here, 2, that gives me 5. So the total distance covered is 150 times 5, which will give me 750 meters. Now I want to calculate the average speed. The average speed is always given as the total distance covered. Average speed is total distance covered over total time taken. So that's my total distance is what I got here. That is 750 meters. I write it down, 750. Total time taken is 100 seconds. Time taken to go from the start to the end of the journey, 100 seconds. That will give me 7.5 meters per second. Right. The next video we shall see another question on this.